in geological terms, we're talking about something really recent. Even in human terms, we're talking about something really recent. We have skeletal remains of anatomically modern humans that go back 300,000 years. We're talking about something that happened between 12,800 and 11,600 years ago. And in geological terms, that's just yesterday. And in many other terms, it's just yesterday as well. In human terms alone, 11,600 years ago just isn't that long ago. And there's no doubt, I don't think anybody could seriously dispute that the episode called the Younger Dryas was a global cataclysm on an enormous scale, and that it led to the extinction of the megafauna, all the megafauna of the Ice Age, all those iconic animals, the mammoths, the mastodons, the giant sloths, the woolly rhinos, the saber-toothed tigers, they all go extinct at that time. That doesn't happen accidentally. At the same time, we know there was huge climatic turbulence, sea level rise, freezing temperatures. It's not surprising that they went extinct. Everybody accepts that the Younger Dryas was a cataclysm. The question is, what caused that cataclysm? And at the moment, there is one major, solidly documented and consistently argued theory, and that is the Younger Dryas impact hypothesis, which suggests that the Earth ran into the path of a fragmenting giant comet. All comets break up into multiple fragments. It's the normal behavior for comets. Every shooting star that we see in the skies, whether it's the Taurids, whether it's the Aquarids, whether it's the Leonids, whether it's the Orionids, all of them are the remnants of comets that have broken up into multiple fragments. And very often those fragments are extremely small, just dust size. And that's what a shooting star is. It burns up in the atmosphere before it hits the Earth. Larger fragments will blow up in the air if they're maybe 100 meters across, like the Tunguska event on the 30th of June, 1908 in Siberia. That was an airburst. The object didn't reach the ground. It's calculated to have been about 100 meters in diameter. It flattened 2,000 square miles of trees. I mean, this was an enormous event.
Serious.
Fortunately, it happened in an uninhabited area. And as far as we know, nobody was killed. But for the Tunguska event to have taken place over a major city would have been horrendous. The result would have been millions of deaths. And it's interesting that occurred on the 30th of June, 1908, because that's at the peak of what are called the beta Taurids. There's a meteor stream that the Earth passes through twice a year called the Taurid meteor stream. And the scientists who are working on the Younger Dryas impact hypothesis are of the view that the Taurid meteor stream is the remnant of that giant comet that caused that cataclysm 12,800 years ago. They think it entered the inner solar system about 20,000 years ago. Calculations suggest that it must have been about 100 miles in diameter, really big. And as it became subject to gravitational forces in the inner solar system, it began to break up into multiple fragments. And in so doing, it became a much wider threat. When it's just one object, the chances of hitting it are actually very low. But when it breaks up into thousands of objects and they start to spread out into a meteor stream that's ultimately 30 million kilometers wide, the chances of running into something big in there are much higher. So the suggestion is that the Taurid, what we now call the Taurid meteor stream, that's simply because it appears to emanate from the area of the sky occupied by the constellation of Taurus. In fact, it's got nothing to do with Taurus. And in past times, it would have appeared to emanate from different parts of the sky. The view is that the Taurid meteor stream is the culprit. It's the remnant of that giant comet. It still has very large objects in it. Interestingly, one of them is called Comet Encke. It's about 6 kilometers in diameter. Comet Encke is a fragment of that original giant comet, Olgiato, Rudniki. A number of very large objects have already been identified in the Taurid meteor stream. 30 million kilometers wide, multiple filaments of debris. Some of those filaments are just small objects. Some of them are very large objects. Some of the calculations by the astronomers suggest that there may be an object that's more than 30 kilometers wide in the Taurid meteor stream, which is completely dark. We've not seen it yet. When comets stop outgassing, a dark tar coats their surface, and they become very, very hard to see. So it's interesting that we had an impact that happened at the very peak of one of the two crossings of the Taurid meteor stream, 30th of June, 1908, the Tunguska event. And this connects us back to 11,600 years ago and 12,800 years ago, when other crossings caused the beginning and the end of the Younger Dryas. The end of the Younger Dryas is harder to explain by cometary activity than the beginning, but it can still be explained that way. The great astrophysicist Sir Fred Hoyle long before there was a Younger Dryas impact hypothesis, was puzzled by the sudden warming and sea level rise in meltwater pulse 1b 11,600 years ago. And he just floated the idea, maybe a fragment of a comet hit one of the world oceans and sent up an enormous cloud of water vapor into the upper atmosphere and caused a greenhouse effect that led to the heating that rapidly followed 11,600 years ago. Just as 12,800 years ago, the world went into a deep freeze, 11,600 years ago, it rapidly came out of that deep freeze and went very, very, very warm. So that's, in my view, one of the best theories. But there are other possibilities. Some of my colleagues in this field believe that it's better attributed to solar activity of one kind or another. I can see solar activity being implicated in the end of the Younger Dryas. I find it harder to see it being implicated in the beginning of the Younger Dryas. What happens at the beginning of the Younger Dryas is really puzzling. You have to picture North America, and North America was the epicenter of the disaster. We're looking at a patchwork of debris that crosses the whole of North America from the west coast to the east coast, goes deep down into South America, actually goes down as far as the south of Chile, continues far east into Europe. The Younger Dryas boundary layer is found in Belgium, and even further east into Syria, where you have the site of Abu Huraira, where the Younger Dryas boundary layer is also present. When I say the Younger Dryas boundary layer, I mean a layer in the earth about the width of a human hand that is full of objects that could only, in that concentration, have been caused by a cosmic impact. Iridium, platinum, glass that's been created by the melting of sand at colossally high temperatures, melted quartz. You need 2,000 degrees centigrade to melt quartz. The carbon microspherules, all these things in abundance brought together. The single best explanation for them is that there was either an airburst or an impact with the ground at that site, and this is found all around the world. So I think the Younger Dryas impact hypothesis, again, it's had its opponents. It's been attacked multiple times. Many of those attackers, one of them is an astrophysicist called Mark Boslow. They will pretend that they have completely debunked the Younger Dryas impact hypothesis, but they have not debunked the Younger Dryas. Every attempt to debunk it has been diligently, systematically responded to by the team of 60 or more scientists, real scientists, behind the Younger Dryas impact hypothesis, and they've debunked the debunkers. It still stands very strongly, and the evidence for it is getting stronger and stronger and stronger every day as more research is being done. And this is one of the very important research projects that needs to be undertaken to understand the Younger Dryas boundary layer, to understand this cataclysm that affected the Earth 12,800 years ago. But yes, there is some dispute about what caused that cataclysm.
Perhaps like a solar flare, solar storm.
That's another possibility, particularly at the end of the Younger Dryas when you get this massive warming. It's difficult to see how the sun could be implicated in a sudden freeze. Yes, solar activity could decrease, but a sudden freeze should not release large amounts of icy water into the world ocean. And that's what happened 12,800 years ago. Not only did the world get very cold, you would expect in a cold spell that excess water would stay frozen on the ice caps. You wouldn't expect it to leave the ice caps, to leave in particular the North American ice cap, and flood into both the Pacific and the Atlantic Ocean, and in the Atlantic Ocean to cut the Gulf Stream, to stop it flowing. The Gulf Stream is part of the central heating system of our planet, overturning meridional circulation. These currents that run all around the planet, they're part of what keep the planet warm, and it's just a plain fact that the Gulf Stream was cut for more than 1,000 years during the Younger Dryas, and it was cut. This is not disputed. It was cut by freezing water flowing into the ocean and stopping it working. But then nobody's asking the next question: what caused that freezing water to get into the ocean in the first place? You know, that's where the Younger Dryas impact hypothesis offers a very good answer. That it's the heat and shock of a series of impacts across the North American ice cap that released that water, that cut the Gulf Stream, and then the world became extremely cold.